All right, so 10.7, which was the last section in the chapter, we talked about circles, or the equations of a circle. So this one said, write the standard equation of a circle with center -3, 5, and radius 2. A quick refresher that the standard equation, if HK is your center and R is your radius, is x minus h squared plus y minus k squared equals r squared. So if this is my h, this is my k, and this is my r, then your equation should be what? Equals 4. Good. So remember, because it's minus in my initial standard form, it's always going to change the signs on your points when you plug it in. Questions on that one? This is the easy stuff. Number 2 says graph the circle. So from this equation, you've got to take out of it its center and its radius. What would be the center? -1, +3, and the radius would be 3. So then I want to come in here, -1, 3, and count to the right. 1, 2, 3, up 1, 2, 3, left 1, 2, 3, and down 1, 2, 3, and then connect your points. Questions on that one? Okay, x equals 2 is what kind of a line? Horizontal or vertical? Okay, it's vertical. If my x never changes, right, but the y changes, x is always 2, then this is a vertical line that would run through 2. Okay, so it makes sense that that is tangent, right? Because tangent would mean what? Touches it at only one point, and then it's asking to identify the point of tangency, which would be what? 2, 2. Oh, no, 2, 3, sorry. So a little bit of application of the definitions of tangent combined with what you know about graphing. Okay, 3. The line x equals y is tangent to the circle in exercise 2. Find the coordinates of the point of tangency. So if I go... Okay, 4 says a circle has an equation of x squared plus y squared equals 4. Determine whether the line y equals x plus 2 is a secant, tangent, or neither. Okay, so I'm going to start by graphing it. So my center, if it's x squared, y squared would be what? 0, 0, and the radius would be 2. So point here, to the right 2, up 2, left 2, down 2. And then it said determine whether the line y equals -x plus 2 is a secant, tangent, or neither. So -x plus 2 is obviously a line, and the b is 2, which means that's where I'm going to start. So I'm going to start at 2. Because the x is negative, that means there's really a -1 over 1 in front of it, which is your slope. Down 1 to the right 1, down 1 to the right 1, and here's my line. So is this a tangent, a secant, or neither? It's a secant, right? Passes through it at more than one point. Questions on any of those? So the questions on your test from this section are pretty straightforward, although these are great application questions. Like, I think these are actually really good questions so that you can pull in the graphing that you obviously needed in Algebra 1 and will definitely need again in Algebra 2. All right, open to your homework. That was due this morning. All right, so 10.1 and 10.2 are kind of blended in together. 10.1 was a lot of the vocab, just based on the segments, the lines, that kind of thing. And then 10.2 was the arcs, so a lot of that vocab is just blended in together. So you're not going to get like a define a diameter with a blank in which you have to give me the definition, but you obviously do have to know definitions in order to apply them to the questions. So the first thing says name a diameter. So in that circle that's there, what would you state is a diameter? I don't even know whose hand went up first. BC or CB, either one works. It's a segment, so you either put the line over it without the arrows or you leave the line off. That's how you identify a segment. Okay, name a radius is next, and this has more than one answer. AC is a radius. AC. Another one. BA is a radius. Okay, and then the A to the top, there's no letter there, but that would also have been a radius if that was named. Okay, name a chord. So a chord that's not a diameter. Let's go that way. Okay. DH, yep. So chord segment that endpoints is on the circle. A secant. Evan, you have a question or you have a secant?
Segment FG.
Yep, segment FG could also be a chord. Technically the diameter could also be a chord, right? All right, name a secant. So what's true about a secant without a secant segment? What's the difference? Good, the secant has the arrows. So there's only one secant, right? Which would be what? FG, good. If it was a secant segment, which is what we used in that last, it's 10-6, then I would say it could be, like, there would have to be a point outside of the circle that I would label, because just FG alone, segment FG is a chord. You have to send it outside. Okay, tangent line, okay, it says it in there, but tangent line, remember there's tangent line and there's tangent segment. So a tangent's going to hit at one point, which would be what? Which one? BC or CB? And it's a line. Name the point of tangency. So we just went over this in the warm-up. The point where the tangent line hits the circle, which would be what? B. Okay, then we get into the arc. So minor is less than half, major is bigger than half, and semicircle is exactly half. So what could be, there's a lot of different answers for this stuff, but what could be a minor arc? Camilla. Arc BD could be a minor arc. Okay, goes from here to here. What else would be an arc? A minor arc. FC could be a minor arc. Okay, BF could be a minor arc. CD could be a minor arc. All of those that are less than half that circle would be minor arcs. How about a major arc? Reagan. So yeah. I'm really glad that you said that though, because GH by itself would just be this little arc. So you'd have to give it a third letter. GDH works. G to D to H goes all the way around. Okay, Madison. B, C, oh, there's two C's. Let's call this, we can make this a P. Okay, B, C, D, that would work. All right, and then we get into a semicircle, which is exactly half. So BC would be a minor arc. You got to make sure that you give it 3 letters, because BC could be the top arc or the bottom arc, right? So you'd have to name it with 3. So give me 3 letters.
BHC.
BHC, good. And what's the other one? BDC, that works too. Evan.
But if you said BC, aren't they both the same size?
They both have the same measure, but you could be talking, how do you know which arc you're talking about, the top one or the bottom one?
But like, if they're the same, could you just say that BC is the same?
No, because what happens if I said, does point D lie on arc BC?
Yeah, I'm just saying for classifying.
You still, if there are 2 ways to name an arc, you've got to use the third letter to make sure, just like with an angle, to make sure that you use, to classify or differentiate between the 2. Okay, so now we've got some measurements occurring here, okay? So central angles were formed by the arc. A central angle that could be, there was like BA and the missing term that's on the top, okay? And the angle equals the arc. So this is saying angle BAF, so these are independent of each other. They don't lead into each other. BAF, we're saying, is 135 degrees. And the question is, what is arc FC? So what would be this arc here?
80 minus 1.
Good. I'd have to subtract 180 minus the 135, and I'd get 45, which would be that missing arc. Because arc BF would be 135. Everybody understands that? Yeah? Okay, I'm going to erase, because again, these are independent of each other. We're going to go to the next one. Angle CAG is 55 degrees. You want to find arc CDE. G. How do I find that? Good. 360 minus the 55, which is 305 degrees. Okay, next one is arc BH, so arc BH and arc HG, sum to 120. Find the measure of arc GC. So what do I know about that whole bottom?
180.
180, so 180 minus 120 is 60 degrees. Questions on that one? Okay, and then arc BFG. Oh, I just read that book with my son. BFG, big friendly giant, 200 degrees. Then find the arc CG. How do I do that? Good. This thing is 200. Take away the top part of it that's here, and I get 200 minus 180, which is 20 degrees. Questions on any of that? Okay, also in this section were the theorems about tangent lines hitting the circle. So theorem 10.1 said, and it was an if and only if, which is why I have it written twice. In a plane, if a line is tangent to a circle, so if I had you want to get a visual, circle and a tangent, what happens? It's perpendicular to the diameter or to the chord, right? The tangent is perpendicular to, not a chord, the radius, which means it's also perpendicular to the diameter. So this is where the Pythagorean theorem came into play. If it said that line was a tangent to the circle, then I assume that this is a right angle, and we could have done a squared plus b squared equals c squared. So you'll see some problems in the review on that. And then the vice versa of that, or the reverse of it, is if it's in a plane, if the line is tangent to the, a line is a tangent, should be if a tangent is perpendicular to the radius of the circle. Other way around, it should be if it's a line. If a line is perpendicular to the radius of a circle, then the line is a tangent. So in that case, they would give you all three of those measurements, and you would show that a squared plus b squared equals c squared to prove that that's tangent. Theorem 10.2 said tangent segments from a common external point, should be point, not points. This is that ice cream cone looking one. What's true about those tangents? They're congruent. So whatever you've got on this side would be set equal to this side. These two would be congruent. And then 10.3 started chords. And the first theorem was if chords are congruent, then, that's later. You're right, but that's later. That's the last theorem in this section. This is about the arcs. So if the chords are congruent, then the arcs are congruent. And if the arcs are congruent, then the chords are congruent. So if this was A, B, C, D, if A, B equaled C, D, those would be the chords, then arc AB would equal arc CD, and vice versa. If arc AB equaled arc CD, then the chords would be congruent. Questions on those? Okay, still in the chords in 10-3. This was the other theorem. So, or not yet to the one you're on, but 10-4 and 10-5, one said it and one said the converse. It said if a chord is perpendicular to another chord, so picture your circle. If I had a chord perpendicular to another chord, then one chord has to be the diameter. If that's the case, then it hits the chord, or hits the, yeah, if then the diameter hits the chord, at its midpoint, and is perpendicular. So this would be, if this is perpendicular, then this is congruent to this. Oh, and it hits, and bisects the chord. Not the chord, the arc. Holy moly, I should have the little cheat sheet in front of me. This would be congruent to this. So if you've got a chord perpendicular to another chord, and one of those chords is the diameter, then the diameter would hit the second chord at its midpoint, making it split into two equal parts, and it bisects the arc. And then the last theorem in this section is the one you guys were talking about before. If two chords are equidistant from the center, so if you could picture this, two chords. So in order to show that they are equidistant, you have to know where the center is, and you'd have to show the perpendicular distance is congruent. If those two are congruent, then the chords are congruent. And vice versa. If the chords are congruent, then they're equidistant from the center. So all of these theorems are on that Quizlet. Like they're in if-then statement form, but you can definitely review them using that Quizlet that's on there. All right, 10-4 is inscribed angles and inscribed polygons. So inscribe has its vertex on the circle, not in the center. And what's true about the measure, the relationship between the measure of the inscribed angle and its arc? It's 1/2. So in this case, angle 1 would equal 1/2 arc AB. And vice versa. 2 times angle 1 would equal arc AB. An inscribed polygon is one in which all of the vertices are on the circle. So just vocab there, because that leads into the quadrilateral part and the angle. So inscribed is all the vertices are on the circle. If an angle is inscribed in a semicircle, then the angle equals 90 degrees. So if I have a circle with a semicircle, then this angle would have to be 90 degrees, okay? If you think about it, it's half the arc it intercepts, and that arc on a semicircle will be 180. Half of 180 is 90. If a quadrilateral is inscribed in a circle, what's true about its angles? Good. Opposite angles are supplementary. So in this case, angle 1 plus angle 2 would equal 180. And angle 3 plus angle 4 would equal 180. Questions on any of those? All right, so 10.5 was all about the angles. The first was that floating angle, or no, sorry, not the floating angle yet. A tangent and a chord. So this is just like an inscribed angle. It's equal to 1/2 the arc. So if I've got an angle that's formed by a tangent and a chord, then it's equal to 1/2 the arc it's intercepted. The next one is those floating angles. So an angle formed by two chords is the arc it intercepts plus the arc its vertical angle intercepts divided by 2. So if they're formed by two chords, like that little one that's there, let's say that this is A, B, C, D, and I'm looking for angle 1. Then I would add the arc it intercepts, which is AB, plus the arc its vertical angle intercepts, which is CD, and divide by 2. And then the last one was two secants, two tangents, or a secant and a tangent. All of them are external angles. And for these, I do the big arc minus the little arc divided by 2 equals the outside angle. So I'll finish the video, but really it's 10.6, which is all the stuff about the chords, the two chords that intersect, the stuff that was on quiz homework, the quiz part of the homework. The two chords that intersect, the whole secant times the external, whole times external, and then tangent squared equals whole times external. Those are the 3 parts of 10.6, and then 10.7 is the circles, with the equations of the circles. So again, I'll publish your chapter review. That's your homework for tonight, and tomorrow we'll go over it. Friday is your test. Okay, and then 10.6 was the segments in the circles. So basically a lot of the same relationships we just talked about, but instead of trying to find the angles, you're finding the lengths of the segments. So the first is if you have two chords. So if I had two chords that intersect inside the circle, and this is A, this is B, this is C, and this is D, then the measure of the product along the same chord are equal to each other. So A times B would equal C times D. And you'll obviously have at least one unknown there. You'll have like 3 measurements and an X, and you just multiply them together and solve. Two secants, and these would be secant segments. This is your whole times the external part would equal the whole of the other secant times its external part. So if this is A, B, C, D, and this is X, Y, let's say, then the whole top part, so the whole length of this segment here, which is your X, times the external part here, which is B, would equal the whole length of the other secant, which is Y, times its external part, which is D. And then the last one in 10.6 was a secant and a tangent. So circle, secant, tangent. And for this one, it's tangent squared equals the whole times the external part of the secant. So if this whole thing is X, and this is Y, and this Z, then it would be Z squared equals the whole, which is X, times the external part, which is Y. And then the last section is the one we just finished, which is the equation of the circles. So the standard equation is X minus H squared plus Y minus K squared equals the radius squared. So the HK is the center, and the r is the radius. So you want to know how to do two things. One is get information out of an equation. So let's say it's this. Then my center would be 3, -2, and the radius would be 4. You also want to know how to graph this. So I would start at 3, 1, 2, 3, down 2, and then I would count up, right, down, and left 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Not a very good circle, but you get the point. And then the other way around. So if I gave you the center and the radius, you should be able to find the equation. So this would be x minus a -1, which is why it becomes x plus 1 squared, plus y minus 0, which is just y squared, equals the radius squared, which is 9. All right, so that's all the content you need to know for Chapter 10. The chapter review is posted on Canvas. That's your homework for the night.